In the focus of the program within the process is detailed process of production from the idea to final result under the brand Made in Kazakhstan. The program shows us an amazing world of projects, technologies and industrial developments.
My phone battery is low. I should charge it immediately. Plugging in the charger, connecting it to the phone, and ready. But the phone does not require 220 volts to charge. This means that this adapter is a sort of a voltage transformer. A device that we all need. But what are they really made of? We paid a visit to a plant that manufactures transformers and are now ready to tell you all about the intricacies of their production process. Hello, you're watching The Process, a program in which we tell you in detail about how it works. Today the lenses of our cameras are focused on the production process of transformers. Work at the plant begins before the workstation machines are launched into operation. First, the design of the transformer is developed at the Design Engineering Department. Here, the engineers take into account all the requirements for a concrete model of the device, depending on its intended use. When the work on the design is complete, the making of the metal tank of the transformer commences. A roll of steel is set up on a special device, a recoiler, and then the machine is turned on, which bends the sheets of steel in a way so as to create a corrugated wall. Because of its shape, when the transformer is used, the warmed-up oil will stretch the steel, but will not tear apart the places where it was welded. This ensures a high level of safety of transformers. After bending comes the welding stage. The places where the steel was bent and a joint need to be reinforced. The work of the welding department is not finished yet. The transformer tank is made up of a great number of additional details. Here, an auxiliary tank is attached to its top. But before doing this tank also has to be cut out and welded. At each different section of the welding department, different component parts for the transformer tank are manufactured. Here, the top and bottom of the tank are bent and welded, and in another section of the department, auxiliary tanks and other details are produced. Because the finished parts and assembled tanks are very heavy and bulky, they are moved around the welding department with the use of beam cranes. When the component parts are ready, they need to be put together. Workers gradually assemble the whole construction, welding the details together. After assembly, we move on to the filing section. The seams on the surface of the metal still have excess material remaining from welding, which has to be removed before commencing to the next stage. Once the transformer tank is assembled, it is time to paint it. Special paint is used for this purpose. When coming into contact with transformer oil, it does not cause a chemical reaction. This paint is applied with the use of a pump spray, a sort of shower for the future transformer. The cover of the transformer is all ready. Now the manufacturing process moves to the next department of the plant. Here, the magnet is manufactured, which will be put inside the transformer tank. Part of the magnetic circuit, the magnetic core, are cut out from electrical steel, which is also delivered to the plant in rolls with the use of a special machine. The core has a complex shape. It is assembled out of a number of steel parts. Separate parts are prepared and cut out for each type and size of magnets in accordance with the shape that is required. The sheet of steel is very thin. That is why a lot of parts are required for one magnet core. They are cut out, stacked, and transferred to the first assembly line department. core of the magnet in the transformer is assembled out of a multitude of sheets of steel. The second component of the magnet is the winding. Aluminum or copper wire is used for this, as well as aluminum or copper foil. CNC, computerized numerical control machines, are used for the winding of the wires or foil. This is equipment that uses numerical control programming. This simplifies the job of the operators. They monitor the proper functioning of the machines and conduct auxiliary operations. Fasten the wire, control the evenness of the winding. This way, the risk of error is lowered and the quality of the manufactured goods is improved. Each layer of the wound wire is isolated. When the coils with the winding are ready, they're attracted to the magnetic core. The second stage of assembly can begin. The top part is added to the magnetic core and fixated. Then the ends of the winding are welded in accordance with the circuit scheme and isolated. Once the magnet is fully assembled, it is sent to furnace for drying for 8 to 10 hours. Now there is a task. We have a finished tank and a magnet. The magnet fits perfectly into the tank, thus the two must be put together. But a question remains. Why is this done? We're about to find out. From the furnace, the magnets are sent to the third stage of assembly. This is the final straight. Here the magnetic core and winding are fastened once again, which includes all the bolts and screws. The top of the tank is attached to the active part. All the outputs are closed off with ceramic isolators. Then the magnet with the top is inserted into the tank of the transformer. Now the tank needs to be filled with transformer oil. This is done in a vacuum in order to remove all air from the inside. As a result, only oil remains inside the transformer. After it is filled with oil, the transformer is considered to be almost finished. But before it is packaged, it is tested here at the plant by connecting it to an electric station and checking the performance indicators under various operational regimes. By the way, aside from these oil-based transformers, there are plenty of other types of transformers. For example, there are dry transformers. They perform the same functions, but are assembled with the use of different technology. Due to the absence of oil, these transformers are more eco-friendly. Green technologies are already here. Not a single house or industrial production can manage without transformers. They are installed and attached to groups of buildings in order to distribute the electric current voltage. Thanks to them, a voltage of 220 volts is maintained in our sockets. Transformers can also lower, increase, and measure voltage. In addition, engineers are developing and realizing unique projects on manufacturing transformers for various purposes and needs. That's it. The transformer is all ready. It can be installed and switched on to operational mode. This plant produces a variety of transformers of various capacities and for different needs. And sometimes there are unique, innovative developments. Engineers here can do pretty much anything. All they need is a reason. That is why the field of electrical engineering is developing at such a rapid pace. You are watching The Process, a program in which we tell you in detail about how it works and thereby change your perspective on things that surround us daily. My name is Nazar Muhammad Jan. Until next time.